Have you ever wondered how apps like Instagram, WhatsApp, or games are actually built? Behind all of them are programming languages, and how powerful concepts like object-oriented programming, also known as OOPS. Hello guys, welcome back to my YouTube channel. In this video, we are going to talk about object-oriented programming. But before we dive into OOPS, it's important to first understand what a programming language is and the main types of programming language. Let's get started with the basics. Programming languages are basically the way programmer talks to the computer. Think of them as a set of instruction that developer gives to a computer so it can perform a specific task, whether it's opening an app, running a website, or playing a game. All of it works because of programming languages. These languages are essential for building software, mobile apps, website, and almost every digital tool we use today. If you look around, almost every piece of technology you interact with has been created using programming language. Now, here's something interesting. Just like humans speak different languages like Hindi, English, or Spanish, computers also have many programming languages like Python, Java, C++, C, PHP. But the truth is, computer doesn't actually understand these language directly. The only language computer understand is binary, which is made up of just two numbers, 0 and 1. So, how do computers communicate with the computers? Programming languages act as a bridge between human and machine. Developers write instruction in a language that human can easily understand. Then the computer translates those instructions into binary so it can process them and perform the required action. Because technology is evolving so fast, there are now thousands of programming languages in the world, but each one is designed for a different purpose. Some languages are used to build websites, some are used for mobile application, others are used for data analysis, artificial learning, or large software system. That's why programmers choose a programming language depending on the type of problem they want to solve. Different language for different tasks, right? There are many different ways to classify programming languages, but in general, most programming language can be grouped into five major categories. One important thing to remember is that a single programming language can belong to more than one category because many modern languages support multiple programming styles. Let's quickly understand these five types. First is a procedural language, programming language. In procedural programming, programs are written step by step sequence of instruction that tells the computer exactly what to do. The code is divided into procedures or function where each function performs a specific task. The common example of a procedural programming language is C. Second is the object-oriented programming, also known as OOPS. In this approach, Programs are organized using classes and object. Object represent the real world entity and contain both data and methods that operate on that data. This structure makes a program easier to manage, reuse, and scale. The popular object-oriented programming languages include Java, Python, C++. They are mainly used for large software systems. Third is functional programming. Functional programming focuses on using mathematical function instead instead of changing data step by step. Function take input and return output without modifying the original data. This approach often results in cleaner, or more predictable code. Fourth one is scripting language. Scripting language are commonly used to automate tasks, control application, or manage system operation. These languages are usually interpreted rather than compiled, which means they run directly without a separate compilation process. The example, the program scripting language example include JavaScript, Python, or PHP. Scripting language used for web development and automation and scripting. Fifth, logic programming. Logic programming is based on formula, formal formula and rules. Instead of giving computer the step-by-step instruction, programmer define rules and facts, and the computer figure out the solution automatically. The well-known example of a logical programming language is Prolog, and logical programming language is used for AI system and expert system. So these five categories help us understand how programming languages are designed and how they solve problem. But in the modern programming, many languages combine feature from multiple categories. That's why a single programming language can often belong to more than one type. Among these types, object-oriented programming is one of the most widely used approaches in modern software development. Object-oriented programming helps developers write organized, reusable, and scalable code by using concepts like classes, object, encapsulation, inheritance, and polymorphism. Now let's look at object-oriented programming. Let's understand object-oriented programming in a simple way. First, object-oriented programming help developers build modular, maintainable, and scalable application. So, what does that actually means? Modular means the program is divided into small parts or modules instead of one huge block of code. Maintainable means the code is easier to fix, update, or improve later. And scalable means the program can grow easily when new features are added. Now, what exactly is OPP? Means OOPS. Object-oriented programming is a way of organizing code using classes and object that represent real-world things and their behavior. Class is like a blueprint or a template. An object is actually thing created from that blueprint. For example, a car. uh, for example, imagine a car class. It represents the idea of a class. From that class, we create objects that can perform actions like start, stop, or accelerate. In OOPS, every object has attributes and methods. Attributes are properties of a data like name, age, ID. Method are the actions the object can perform. For example, run, speak, calculate, because basically an object stores data and performs action. OOPS also organize programs into classes and objects, which makes code much cleaner and easier to understand. Instead of writing one long complicated program, programmers sorry developers divide the code into smaller structured pieces. Another important concept in OOPS is encapsulation. Encapsulation means grouping data and method together that works on that data together in one place. It means grouping data and method that works on that data together in one place. It also protects the data from being changed incorrectly. For example, in a bank account class, the amount, the account amount, and the method like deposit and withdrawal are kept together. Next comes the inheritance. The inheritance allow one class to use to reuse the properties and method from of other class. It saves time and avoid rewriting the same code again. For example, a vehicle class may have a common features like speed and fuel. Then in a car class or a bike class can inherit those features from vehicle class. Another key concept is polymorphism. Polymorphism means one method name can behave differently based on the situation. For example, imagine a method called move for a car. Move means driving. For a bird, for a bird, move means flying. Same method name, but different behavior. Because all these concepts, because all these concepts, oops, improved modularity, scalability, and maintainability. Programs become easier to manage, easy to expand, and easy to fix when problem occurs. So in simple word, object-oriented programming helps developers write organized, reusable, and easy to maintain programs using classes, object, and concepts like encapsulation, inheritance, and polymorphism. So far, we have seen what is object-oriented programming and the different concepts that are involved in it. So, so far, let's see them in detail. Let's start with an important concept in object-oriented programming, classes and object. So, what is a class? A class is a blueprint for creating objects. Means a class can be understood as a collection of objects. In simple terms, a class is like a category or a group that contains similar object. For example, imagine different cars like Toyota, Hyundai, and BMW. Even though they are different cars, they all belong to the same category called car. So we can say that they all belong to a car class. Class as a blueprint. A class is also known as blueprint, design, or template for creating objects. Think of it like a design of a house. The blueprint shows what the house is. The blueprint shows that what the house should look like, but the actual house is built from that design. Similarly, a class defines the structure, an object create the object created based on that structure. For example, a car class may define things like color, like color, speed, or model. These define what a car should have. Attributes and method. A class also defines attribute and method that its object will have. Attributes are variables that store data about an object. For example, car can have, for example, color is similar. Color, speed, model. These describes the property of the object, whereas methods are functions that defines the action the object can perform. For example, start, stop, accelerate. So in simple terms, attribute stores data, whereas method performs action. Now let's look at encoding. As you can see here, a class is a collection of objects. Classes are the blueprint for creating objects. A class defines a set of attributes and methods that that the created object are also called an instant can have. Some points on Python classes are created by keyword class like this. This is a keyword stored in Python internally. Attributes are the variables that belong to class like this. You should also know that attributes are divided into two types: class attributes and instant attributes. Attributes that belongs to an instant instance means objects, where attribute that belongs to a class, this is a class attribute, right? We will look at the instance variable later. Attributes are public, always public, and can be accessed using dot. What is happening? Can be accessed using dot method. For example, my class dot attribute. Let's look at the example by coding. Class is a keyword and my car is a class name. In Python, a class is created by using the class keyword, as you have seen here, class class in blue. Here my car is the name of the class. And what is pass? Pass is actually a keyword that is used to make semantically correct semantically code correct. If I don't write pass here, it will start throwing error. So when we create an empty class or an empty function, we use this syntax. Here it is an empty class. This is a empty class. Empty class called my car. And these are the class attributes. So what are these? Attributes that we have that are always public and can be accessed using dot operator. This is a dot operator. This is my class and this is my attributes. See, red and Toyota, red and Toyota. Now let's look at what is objects. Object is an instant of a class. Object is an instance of a class. In simple words, object is actually a thing created from that class blueprint. This car1 and car2 is an object of, of my class name my car. Object it represents a specific object represents a specific implementation of a class and holds its data. What this means, even though the objects are created from the same class my car, each object has its own data. Each object have its own data. Like we have created before here. By default, color of my class is red and brand is Toyota. But here we have changed the color for my object car1 and car2 and printed using dot method. So both objects belong to a car class, but their color are different, right? An object an object has three main components: state, behavior, identity. So what is state? It represented by attribute and reflects the property of an object. Means the state of an object represents the data stored in it. In simple words, it's data stored in it, right? So color describes the state of an object. So what is behavior? Behavior it is represented by by the method of an object and reflect the responses of an object to other objects. It means, in simple word, it means an action an object can perform. These actions are defined using method. Here we have not used method. We will see that later. So these methods represent what object can do. Here we can add like car can start. We can write as car start or car stop. Next is identity. Identity means every object has its own unique existence in memory. Means it gives a unique name to an object and enable one object to interact with other object. Even if the two objects have the same data, they still are different objects. See, same classes but different objects. Even if I don't give, even if I don't modify the color in both the object, so the original color was red, it will remain an original color in car 1 and car 2. Still, it will be two different objects. Both are identical objects, but with different identities. Let's quickly recap. In class, the blueprint, right? Or design or template. An object are the real instant created from their class. Attributes are data or variable or properties. And methods are the functions or actions. State, they are the data stored in an object. What are behaviors? They are the action the object performs. An identity, and unique existence. Of an object. Now let's look at another example. In this example, we will create another empty class named my class. My class. You should know the naming convention of a class name is different from that of name, naming convention for variable or functions. The class name should use cap word. Cap word convention. Cap word is nothing but the words should start with capital letters. Right? Here in my class, M is capital and C is capital. Okay, and we have typed pass. I've already known why we have used pass, right? Then we will create two objects, obj1 and obj2. Then we will print the type of obj1. And print the type of obj2. Let's see what it gives. See, class underscore main underscore dot my class. So what this means is class and object are being defined in the same module. What is this? And double underscore main double underscore means it's a dunder method or also known as magic methods. This means my class is defined in the main file you are running. It's an object and the obj1 and obj2 belong to this class. Now let's look at another example. In this case, as you know, all data types, this is important, all data types are classes. Let me show you with the help of example, right? Let's say we have a list in which name fruit, in which we have mango, orange, another one is apple. This is the list, right? If we type print and type of fruit, what will we get? See, class list. This proves that the list, which is a data type or data structure, is a class. Similarly, art string, tuple, dictionary, these are all classes. So a list is a class and this fruit is a type of that class, which means it's an object of the class. It stores some data, mango, apple, oranges. These are the data or the attribute associated with the fruit, which is a class, which is a list, right? And we can have the functionality of this fruit list object. How? We can append, remove a new fruit to it, and there are many more methods involved in it. We can see that with the help. If we do list, it will give you a documentation of it. See, in it, these are the method defined within the list class. The danda method, this is a append, clear, copy, count, extend, index, insert, remove, reverse, sort. These are all the methods in the list. Right? If we want to use the functionality, what do? We use dot method. Dot append. If we print it, see, banana is added to it. So when I do this is nothing but dot operator. A dot operator that after a function get applied to it after the fruit object. So for creating an object, we need class, right? We can create multiple objects using the same class. So far we have seen the attributes. So if I want to basically use any method on an object obj1 and obj2, we should be able to use it with dot notation. That we saw before. Here, fruit example, this one. But right now, we don't have any method defined inside my class. To have method, to have the method called by an object, we need to make sure that the method should define inside my class. Now, what are methods? Methods are the function defined within the class. Any function that gets defined inside the class automatically becomes the method. That's why we can say append method. We say append method, not append function. So how to call these methods? By using dot notation. These methods nothing but function defined inside the class. So they can have argument like bananas, and they all follow the basic concepts of function remain the same. One more thing, if we have the doc string, let's say this is my class, this is my class, right? So how can we access the doc string to it? We can do it with the help of an dunder method. Let's say print my class dot double underscore doc double underscore. If you print it, we will see the document doc string inside my class. Okay. One other method we have seen, the help. Okay. Like this, help my class. This will be the doc string. So what are attributes? Attributes are the stored data specific to an object, distinguishing it from other objects of the same class, while methods define what an object can do. Attributes define what an object is. As you have previously seen, the state and behavior. State is an attribute while behavior is a method. Let's look at another example in which we will use methods. Before I write code with a method in it, let's see one more example in which I I have to tell you something in this. In this example, student, then we will have two objects of students. Then we will give attribute to it, but this time we will not give attribute inside the class, but we will do it manually. See, in this we have give the object attribute, but we have done it outside, not inside the class. Let's print it. So what is the difference between writing code this way, means writing attribute manually, and writing attribute this way. In this, we generally write this attribute inside a class, and when we create our object, automatically these attributes become a part of an object. But here here we define the attributes manually. We can do this technically, but that's not ideally we should do. Why? Because let's take it with let's imagine, let's say, example of a laptop class or a laptop manufacturing company where the design has been created. Let's imagine that we do not create an attribute RAM in the design. Okay, we have created it. Laptop class. Inside it, we forget to write an attribute of RAM. We do not create an attribute RAM in the design. We do not consider, at that time, we do not consider RAM to be the component of a laptop. This is our imagination, right? Now, when I create each laptop, right, when we create physical laptop using the designs, all the laptop will be created, but without a RAM in it. And that's a burden. That should not be the case. So how to fix it? There are two options. First, we discard all the created laptop without a RAM. That would lead to a lot of losses. That's not optional. And the second is to install RAM in these laptops. In either cases, it's an epic task that we should avoid. That's why we have to make sure that the design has all the attribute before we create any object of our classes. Okay, that's it for today. In the next class, we will see what are instant variable, instance method, instant method, initializer, constructor, constructor or initializer, static method, inheritance, encapsulation, inheritance of various type, single inheritance, multi-level inheritance, multiple inheritance, polymorphism, abstraction. In abstraction, polymorphism, we have method overloading, method overriding, duck typing, and in abstraction we have abstraction class, abstraction method. This will be learned in the next video. That's it for today. Thank you.